A warm greeting to everyone. I am D.M.Kalai Selvi, Assistant Professor, CSE Department, R&D Engineering College. Now we are going to see about collision resolution technique in data structure. When we say it as a collision, when two or more key values going to map to the same location in the hash table, we will term that one as a collision. So we will see some techniques to overcome that collision. Some of the methods for overcoming the collisions are separate chaining and open addressing. Under open addressing, we have linear probing, quadratic probing, double hashing. Separate chaining is nothing. We are going to list all the elements that framing that collision problems into a chain of items. For example, if we take 0, 1, 4, 9, 16, 25, 36, 49, 64, 81. These are the keys you are going to add it. And we will be doing the hash function. So 0 modulus of 10, 0. And 1 modulus of 10, 1. First we'll be adding this one. And then 4 modulus of 10, 4. 16 modulus of 10, 6. 25 modulus of 10, 5. 36 modulus of 10. Already we have 16. So here we'll be having a collision and we'll be for chaining it. Just using like a simple linked list, we will be listing and give a connection between all the items in the between the same collision area. Next is open addressing. So the disadvantage in open separate chaining is linked list. The implementation of linked list will definitely a probable one. So then we are going for the other option for open addressing hashing system. So here what you will be doing is you will be increasing the table size. So when we will be increasing the table sizes, when generally the load factor value should be less than 0.5. There are three methods under this open addressing: linear probing, quadratic probing, and double hashing. So first we have that some set of data. I will explain what is meant by linear probing with an example. First we have some set of data. The table size is 10. So first we are going to add 89 mod 10. So the value will be 9. 89 is added. And next is 18 modulus of 10. So 89, 18 will be added. Both two things are added. And after adding 49, 49 will be added to the location 9. In 9, already we having the 89. That means here we'll be calling the probing function. H of x is equal to so the probing function we'll be having a probing counter iterator value. Initially it is I is equal to 1. Now we have already 49. So 49 modulus of 10 we're having 9. 9 plus 1. We'll be adding the probing value 1 equal to 10. And again, we are doing the modulus functions. 10 modulus of 10, 0. So at location for 0, 49 will be added. That only we have seen as a formula here. we will be having a linear function, typically I, which will be incremented based upon the collision. Next, we're going for 58. A 58 modulus of 10 will be 8. Already with the counter value is 1. Next, for the counter value will be incremented to 2. 8 plus 2. First, 8 will be there. 8 already collision occurs. So 8 plus 1, 9. 9 modulus of 10, 9. 9 already collision is there. Next, 8 modulus of 2, 10. 10 modulus of 10, 0. Already item is there. Collision is there. Next will be 11. 11 modulus of 10, 1. So at location 1, 58 will be added. Next, we take for 9. 9 modulus of 10 will be 9. 9, but collision occurs. So we will be calling the probing function 9 plus 1, 10. 10 modulus of 10, 0, collision occurs. Next, we go for 11. 11 modulus of 9, again collision occurs. Next, we go for 12. 12 modulus of 10, 2, at location 2, 9 will be added. Next is quadric probing. Here, what's the difference between linear and quadric probing is here you will be incrementing that probing value in squaring manner. So I square. So H plus I square will be done. So the same table at location 9, 89 modulus of 10, 9, 89 will be added. Next, 18 at location 8, 18 will be added. Again, 49 at location 9, 49 will be added. If you take here, that in this only probing function, so 9 plus I value, that is initially it is 1 square. 9 plus 1 square is also 1. So at location 10, 0, 10 modulus of 10, 0 at location 0, 49 will be added. If you take for the next thing, 58, 8 will be the answer. So the probing factor will be 2. 8 plus 2 square. So 2 square will be 4. 8 plus 2 square will be 4. Then 12, 12 modulus of 10, 2. So at location 2, 58 will be added. We go for double hashing. So the last method is double hashing. That is, you will be defining on one more hash function, a second hash function to derive the collision resolution. So f of I is equal to I value. So the I value into hash2 functions. The definition of the hash2 function is R minus X modulus of R. So R will be the prime number lesser than the table size. The general collision, which one will be the best one? That's a graph for representing for successful search. Linear probing is the best one. For unsuccessful search, also linear probing is the best one. Thank you.